Hello, after some inspiring conversations with some pretty bright people, I have been motivated to move my entire home infrastructure into containers. And I thought I would document this process so that the strategy I'm using might be of benefit to others looking to do the same thing. And the first thing we're going to do, the first service that we're going to move over, Pi-hole, because it's pretty simplified as far as the container deployment goes. We're going to do this using a two-phase process. I'm going to do this with each service that I move over, and you can go ahead and pause the video now if you want to read this. But the summary is we're going to do everything first via Docker in a VM, and we're going to get all that working, take care of dealing with the certificates as well, do a planning phase on the volumes, databases, and certificates, and how that's going to work within uh, Docker. So in such a way that if you were to spin up an updated container, it's just going to move over and take advantage of those volumes, databases, and certificates without having to redo all that. Because that's the way you got to think about things when you're implementing in Kubernetes. And current day, this I would have implemented with Ansible at this point and kind of left it as is. Infrastructure as code works just fine. But since we're planning to move to Kubernetes, there's going to be a second phase. And in phase two, it's going to be similar. We're going to spin it again, use a VM and Docker, but then we're going to install Minikube and get everything to work with Minikube. That'll involve setting up the certificates that we had generated before as secrets within Minikube, and then get everything working within Minikube. And then instead of Ansible, we're going to use a DevOps pipeline. And in this case, we're going to use Jenkins because we're in a home network. And um, I'm suggesting we might want to have an option to regenerate certificates, um, and as well as an option to deploy into production if all the unit tests pass. So we are working with a home network environment here. So I can generate things and dump them into production. And if it breaks, I don't really mind so much. It's only going to affect me. So it would really just be a good learning experience. But of course, in real world production environment, you may want to have a human involved there at the end to make sure whether or not you actually want to drop things out into production. However, that really, in my opinion, comes down to unit tests. It's unit tests, you can continue to add more and more over time. And, eventually, I would almost trust my unit tests more than having somebody just work with the product for a while, right? If I write, several unit tests, of course, the number is going to depend on the product. Eventually, I could write more unit tests than I could really test myself quickly. And eventually, from a QA perspective, those start to become something that you can trust more than, say, deploying it to the IT staff and seeing, if any problems occur. Because deploying to a group doesn't mean they're necessarily testing out all those features. But I digress. Don't need to talk about QA too much. That's going to be your call. So on to phase one. So phase one, step one, we're going to create the VM in my home network. I have Ansible set up to create VMs. So I'll go ahead and kick off that process. And no need for us to wait around. I'll just pick up the video after this finishes. Okay, VM has been built and now it's time to install Docker. I'm not going to recommend Podman. You can if you like, but what I recommend is installing Docker and not installing whatever the OS provides, but rather going out and getting the latest stable version, which is exactly what my Ansible script does. And again, we don't need to wait and watch this happen. I'll go ahead and pick up the video after it finishes. All right, Docker installed. So as part of that first step, I mentioned to install the CA certificate authority. And this is a thing. It's quite important to the point that I've already actually added this step into my Kickstarter file. So I don't need to do this step, but I wanted a chance to talk to you about it because in the world of Kubernetes, managing all these containers, certificates become a big deal, right? You may have already experienced this if you're somewhat new to Docker and running containers, that as you add more, 3, 4, 5 containers, they all have ports and you got to work with that. Okay, well, they all want to use port 80 perhaps, but inside the container, maybe they have port 80, but then you're mapping them to a different port externally with on the actual host machine. And then there are techniques to map based on the certificate, based on the host name that they come in with, that maps to the correct port. So the actual user doesn't know what port's being used. At least in the world of Kubernetes, that's the way it works. So you need to start working with generating the certificates and making that work. And in order to work on your local LAN, you're going to generate the certificates and they're all going to trust the CA, right? The certificate authority. And in order to trust that, you have to have that installed. So with what we're working at, we're installing it to the local machine. And does that get recognized within the container? Well, using Docker, a lot of the times it does. In the world of Kubernetes, it's not going to make a difference. But on the local machine, sometimes it's recognized within the container, which can make your life a little easier. But oftentimes you'll have to do an additional step within the container, which we'll see later on, to either import, and extract that CA within the container, or to use something else if it's a different technology such as Keytool if they're using Java. It I can tell you that you're going to run into this, and it may seem overwhelming and frustrating at first. I wasn't sure what was what I was running into. Like, is this going to be an ongoing issue? But pretty quick you find out, like, hey, there's there's really only a few techniques that everybody's using, and after you've implemented each of those techniques once, you'll recognize it when another container is using that same technology, and then you can use that same technology or the same technique that you've already figured out. So it's no longer a big mystery. They're going to use one of the technologies, and then you go ahead and perform that one. But um, I have added it as a Docker step. So just for fun, I'm going to go ahead and run it. It is configured as idempotent, right? So it's not going to break an installation that's already set up. So yeah, I just kept it in the notes because I wanted to share that information with you. And we'll go ahead and pick up after this finishes. All right, CA certs have been installed. Let's go ahead and go to the next step of getting it all to work with Docker. So I'm going to go ahead and remote over with the Secure Shell, and I did the -X that allows me to use X server redirection, and I've already got that set up. So I'm going to go ahead and start up Chromium so that I can, well, you'll see. Good for testing. And I'm going to use it to get the steps to create the Docker container. All right, starting up Chromium. We're looking to figure out how to install Pi-hole. A little delayed with the port redirection. Hopefully not that bad. This animation is slowing things down. Let's switch to a new tab. Okay. Installation. Looking for the Docker install. There we go. Official Docker images. So sometimes you grab somebody else's and sometimes they're official. Always better if they're official. And the main reason I can think of for that is that when using containers, you're referencing volumes and database information. And at some point, you want to replace that container with a new container. And if it's supported strongly by the producer of the container, by the app developer themselves, then they're going to keep in mind that somebody's running an older container and then moving to a new one. And if they save data in a different way, they're going to be more aware that they may mount a volume that has an older format and handle that appropriately. Whereas if you're using a container that's been created by a fan, or however you want to word it, and the application developer isn't necessarily aware that their program's being used in a container, when that container updates to the new version, it that application may see an older format of data and not handle it as well. But in modern day, I think everybody is aware of containers, or at least it's moving in that direction. So people are developing with much greater awareness that what they're producing has a good chance of being run in a container. So handling that older data probably won't be such an issue, at least I don't think it's going to be much of an issue. It's really the only possible bad effect of using containers that I can think about. So as long as people have a good awareness of it, should be less and less of a problem going forward. Working with Kubernetes, you can always roll up, or move to the next an updated container and roll back if there's an issue. All right, so here we are on the page where they're documenting it. This is pretty common without reading a lot. I'm just going to kind of blindly copy this and use it. It's talking here about running dash dash detach to start it up. So let's see if we can just copy paste this and get going. All right, here we go. I'm reading this same page on another window and learning about how to customize the container. All right, Pi-hole is up and running. So I'm taking a look at the possible customizations. Changing to Denver. Setting my DNS server, my local DNS server, which can resolve my um, local hosts. That's where my DHCP is. Pi-hole can also be your DHCP server if you so choose. All right, and I know from some past experience that I need to set these both to false. The instructions have quotes around the Boolean value. I'm not 100% positive if that's going to work or if I need quotes around this DNS here. Let's just give it a shot and see if things get better. That didn't run with detach. $62. All right, so if I haven't mentioned this before, .pyhole is a DNS resolver, and you can use it to block ads. For example, with the mobile phone is my main goal here. My mobile phone is connected to my home network via a VPN, and I can get this domain DNS to resolve things, and hopefully that'll remove ads from my phone. All right, and it's resolving localhost as well. So everything is working the way I would like it to work. Let's go ahead and set our initial password. I'm getting this from the directions here at the bottom. It's giving us the command we can run inside the Docker container. So I'm passing what's needed to run a command inside the Docker container. Let's give that a shot. All right, so we've got our admin logged in, got a couple of clients here, and I think we are good to go on this step of phase one. Next, we want to generate our certificates and connect from outside systems rather than just local hosts. I'm going to go ahead and open up the ports. All right, so we got that warning that we need to possibly specify the zone as Docker, but at least for our use, it doesn't seem to be relevant. Okay, so to generate a certificate, you're going to have to generate a certificate signing request and then go over to the certificate authority and sign that request. Generating the certificate signing request will generate a private key, and what you get back from the CA will be your public key. I have this set up in Ansible as well. All right. So we've got our public certificate signing request here that the CA will sign for us. I'm going to do that off camera. I'll be back. All right, so what you can see on my screen here is a search directory in the home directory over on Pi-hole. That's created when I generate my certificate signing request using Ansible. And you can see in that directory the CSR, that's the signing request key, which is the private key. And then you can see me here after a couple commands, I'm using cat to pipe in the certificate, which I got from the CA. And I just pasted it into this window, and now we have our certificate here as well. So we've got our private key and our public key, which I'm going to rename to just TLS. Here, I'll go ahead and display the, well, this video isn't about generating the keys and whatnot, but here's the certificate signing request script that I've put together to generate my keys. And you may want to model this. There are issues if you don't have this section down here, which is sometimes not covered in the, 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 the help that you may find online. So you can see all I'm doing here is providing an alternate name, and then I'm specifying the fully quiet domain. You can also specify an IP here, and I'm suggesting at this point in phase one not to specify the IP. That allows us to generate certificates which are not IP dependent. And for a home infrastructure, this could be just fine as far as signing things goes, just to make things work, but a little bit more official, but not super locked down with security. My take on security in this case is you probably do want to have an IP as things move on to phase two, and it's going to be eventually the IP of the Kubernetes server. For now, though, this should work. All right, you can see up at the top left over here, back over on Chromium, that we do have a secure connection to our Pi-hole server. And I've got up here on the screen the steps that it took to make that happen. There was a lot of troubleshooting, but we eventually got there. So we need to enable in the compose file the port 443. Got to set it up to forward that port, of course, from the host, since we're using the VM for now. We got to add our certs to a volume that the container can have access to. Then we got to go into that container and make a change to a file. So later on, when we have a pipe, we're going to have to somehow automate these steps, of course. And here we've went ahead and added in a redirection in case somebody goes to the HTTP. We want them to use the secure connection only. Then we restart the service. It turned out there was a bug here. If you're using HTTPS, we had to make a change, and all you got to do is replace this one file. So we're going to have a sed in our automation to do that line replace. I may or may not implement this in Ansible. The only reason to implement it in Ansible at this point would just be record the steps. But since I've got the steps recorded here in this README, that might be good enough. Might be time to move on to the phase two. All right, phase one complete. So what did we do? Well, I don't need to say all these steps. What I'd like to mention specifically is that volumes, databases, and certs, we didn't really talk about a planning phase. I mainly put that in there because I wanted you to think about it. So for example, we used volumes in this case. There wasn't a database. Specifically, we didn't configure a database, although there is a file that's called a database that sits on the volume. So the software is thinking of that file as a database. So in this case, everything's being used through volumes. And as we spin up a new VM and we install Minikube in the next phase, we're going to essentially start over. But what if we had wanted to move those volumes over? Wouldn't it have been maybe smarter to have used a network share, and then we could simply reference that network share in the new location? So it's something to think about. Otherwise, this concludes phase one and on to phase two.